2.6, 2.7, number 16, you have this rational expression, and it's a little more difficult. So I already did the factoring for mine to speed up the process. You may want to do the quadratic formula to get your two answers, and then you write x minus each of those answers, if you remember back to chapter 2. So, and then when you do that, if you have fractions, remember to bring the denominator out in front. And basically on the top, right, because you're going to get two answers, but you won't have a 5 in front, so you have to multiply one of your expressions by 5. It's pretty difficult to do, but this is what I'm getting for mine. Now, these two essentially go away, and this is what the problem is going to behave like. So if that x minus 2 goes away, that's telling me that there's a hole. So not a vertical asymptote this time, there's a hole at x equals 2. And if it's behaving like this part, what I can do is put the 2 in for x. And I get 10 minus 5 on top, and 10 minus 5 on top is 5. 2 times 2 is 4, plus 1 is 5. So when x is 2, my my output's 1. So that's where the hole is located. Now, we still would have a vertical asymptote, and that's going to be located where this thing is 0. So now let's take the other one. So I take my 2x plus 1 and I set it equal to 0, and I subtract 1. Then I divide by 2. So when x is negative 1/2, that's where my vertical asymptote would be. So I have a hole and a vertical asymptote. To find the horizontal asymptote, I take the degree on top, which is a second degree largest exponent, and another second degree on the bottom. And so then you do the leading coefficient rule, and that is 5 over 2. So my horizontal asymptote is 5 over 2, or 2.5. And the slant would be D N E. There's no slant. It has to be a big over small. So that's how we're doing this problem.